In this next video, we're continuing with our review of quadratic functions. Now we're going to move into vertex form and transformations. So in this problem, we have a standard form equation. We're going to identify the vertex and the direction of opening. So anytime you're doing that, you're going to use the formula x equals negative b over 2a. Here my a is 5, my b is negative 10. So I'm going to plug those in. So I have a negative. Then for b, I'm plugging in negative 10 over 2, and a is 5. Here on my numerator, two negatives become positive. So I have positive 10, and on the denominator, 2 times 5 is 10. So my x value for the vertex is 1. Now if I want to find the y value, I'm going to plug 1 in everywhere I see an x. So here I get 5 times 1, because 1 squared is 1, minus 10 times 1 plus 9. This becomes 5 minus 10 plus 9, or negative 5 plus 9, which is equal to 4. So my vertex has an x value of 1 and a y value of 4. So my vertex would be at 1, 4 for this problem. It's also asking the direction of opening. For direction of opening, you look at your a value. If it's positive, it opens up. If it's negative, it opens down. So here my a is equal to 5. That means since it's positive, that it's going to open upward. In this next question, we're going to identify the axis of symmetry and direction of opening. So axis of symmetry is basically your x value from your vertex. So we use the same formula, that x equals negative b over 2a. Here I plug in negative, b is 8. On the denominator, a is negative 4. So this becomes negative 8 over negative 8, which is 1. So we're not finding the whole vertex, just the axis of symmetry. So we already have our answer. Our axis of symmetry here would be x equals 1. And then direction of opening, remember that comes from our a value. So here our a is equal to a negative 4. Since it's negative, the direction of opening is going to be downwards. In this next question, we're going to convert this equation to vertex form, which is the y equals a times x minus h squared plus k. And it's already telling us that our vertex is at negative 4, 3. So to convert to vertex form, you need to know a, h, and k. So our vertex, which is negative 4, negative 3, gives us our h and k. So here our h is negative 4, our k is negative 3. And then our a, we know from the original function, that's right here. It's equal to negative 2. So our a is negative 2, our h is negative 4, our k is negative 3. And we can plug those into the equation. So for a, I'm plugging in negative 2. For h, I'm plugging in negative 4. And for k, I'm plugging in negative 3. Now, we don't want to leave double negatives here. So anywhere I see a double negative, I'm going to change my signs. So I have y equals negative 2. Here, two negatives become positive. And if you have a positive and a negative, it stays negative. If you remember, I also taught it another way where you can change and keep. So if you notice here, this changes to a positive 4. And then we keep the negative 3. So that's another way you can do it, so you don't have to worry about those signs. In this next question, we want to know which is the graph of y equals x minus 4 squared minus 6. It's easy to locate the graph if you know where the vertex is at. So remember, for your vertex, you're using your h and your k. And we learned to locate it, you change and keep. So we're going to change negative 4 to positive 4, and then we keep the negative 6. So let's check which graph has a vertex at 4, negative 6. Here, that would be graph 3. You look, this other one here is at 6, negative 4. This one here is at positive 4, positive 6. And this one is at negative 6, positive 4. This next question wants us to identify the vertex and describe the transformations that took place to create this equation. So my vertex comes from my h and my k. And remember, we're going to change and keep. So my vertex here is going to be at, instead of positive 5, I change to negative 5, and I keep the negative 1. Now for transformations, I'm going to go from left to right. So this negative sign means there's going to be a reflection. The 1/3 is smaller than 1. Which means there's going to be a compression. And that compression will be by a factor of 3. When you're doing stretches and compressions, you just use the whole number, not a fraction. Now, the plus 5 is in parentheses. So that x plus 5 that's in parentheses is telling me it's going to move left 5. Remember, plus is left, right is minus. And then that minus 1 at the end. So that minus 1 at the end is telling me it's going to move down 1. So that would be your vertex and the different transformations that would take place here. And this next one, it's asking what type of transformations occurred. So we're going to compare it to the parent function, which starts at 0, 0. So here we can see it moves down 2. And it moves left 2 to get to the new vertex. So it moves down 2 and left 2. This one's facing upward, so there's no reflection. But let's look at our A. So when it moves 1 to the side, it actually goes up here. So that means our A is equal to 1, 2, 3, 4. Since our A is bigger than 1, that means we're going to have a stretch. And our A is 4, so our stretch is by a factor of 4. Here in this next one, it's asking what type of transformations occurred. So let's look at our vertex first. Here to get to the new vertex, it moves left 3. And then if I look at my graph, it's flipped. So that means it's negative. So that means there's a reflection over the x-axis. I'm going to go back a few problems really quick because I just remember here I forgot to specify that the reflection would be over the x-axis. So when you're doing your reflections for these, it's over the x, not the y. So this one is negative, so it has a reflection. If we could look at our A value for this one, it's only moving down 1 square. So since it's only moving 1, there's neither stretch nor compression. So this one moves left 3, and then it has a reflection over the x-axis.